Okay, so let us start. Hello everybody. My name is Kreuzer. I'm working for Deutsche Telekom, and I'm here to introduce you to the Eclipse project, a rather new one, the Smart Home project, where I'm the project lead. And yeah, we talk about IoT here at the IoT Theme Day, and there are many other words floating around, like M2M, Internet of Everything, and so on. So that already gives you an idea that more or less talking about IoT, everybody means something else and talks about something completely different. So for the start, I just want to give you an idea of what exactly I want to talk about and what Eclipse Smart Home has in the scope. So to me, IoT can be actually separated into mainly two main topics. That's the one part is the industrial IoT, how I call it, which are really the M2M solutions, sensor networks, distributed setups. We really develop business solutions. The other part of the IoT to me is the consumer IoT, which are all the nice IoT devices that are out there on the market that you can buy as a consumer, hook up to your Wi-Fi at home and do something smart with that. Now, for the smart home, it's not only then about these IoT devices, it's also about the classical home automation part. Where you want to have more and more things electrified, like having electric shutters, all your lighting you might want to control, and other things. And this picture already gives you also an idea that the more and more electrification in the home also means some change in what you actually want your electrician to do. Because if you have a room with four shutters there, you don't really want to have that many buttons at your wall, but you might want to have one central switch to do that. You might want to have them automatically operated and so on. So to me, such a setup here at the wall is really a nightmare at home. Yeah? To have that many buttons where I can hardly remember which one was now which light, right? So these two things, the classical home automation and the new IoT gadgets, this together is more or less what we look at Eclipse Smart Home. Okay, so let's have a look at these IoT gadgets that are out there. Here you see a couple of them, and you end up more or less with a smartphone like that, so having many separate applications to make use of your devices. And that already shows you that there's actually a problem of how you can use them at the moment, because although they are all part of the Internet of Things, they are not connected. They are all siloed solutions. You can use them one by one, but you're becoming more or less the integration point between the things. You get a notification from the one application, and then you might do an action on the other application. But it's not that these things would work directly out of the box together. If you have another look at how the setup works, it's actually that every device or system that you buy there connects to its own cloud service from the manufacturer, which is then used by the smartphone application to have remote access and to have the notifications and everything. So if I look at this picture, it actually makes me very depressed, because it looks like a rainy day, doesn't it? And this setup, that can't be really the solution to things. So one other problem between having, besides having siloed applications here, is that you really depend on every single cloud service there. First of all your data is spread out there. You can't really even combine that and make useful things. And you depend on the services, and there are so many startups in this area and so on. There will be a phase of consolidation someday. And what happens if one of these cloud services disappears because the manufacturer doesn't exist anymore? Well, your devices that you bought for a lot of money are actually useless at that moment because you can't use them remotely and all the functionality that you bought with them is lost. Another aspect is that what we've just heard from Paul before, heating system manufacturer might not be the biggest expert in securing a cloud service, right? So having all these many connections from all your different devices out to some service, each of them is really a vulnerability risk to you, because through every single service somebody could get and hack into your home. And we've seen already some press coverage around such things in the past, and I'm pretty sure that there will be more and more coming in the future. Now, for the smart home, to me it's also important that you shouldn't be completely dependent on your DSL or internet connection at home. Because if you just talk about these small gadgets, which are more or less a toy that you might use or might not use, it's okay. But if your light switches don't work anymore because your DSL connection is down for a moment, then you're really in some trouble, and you wouldn't want that. So for all of these reasons, what I say is that actually the perfect architecture and setup would be that all your devices are really connected on your local network, and they should be usable there. So that's why I'm talking about an intranet of things. They should all be on your intranet, and you should be able to use them there. You shouldn't depend on anything outside, at least for the normal, standard and basic functionality. Now you could say, okay, these devices are there, they're all IP enabled, they could now directly talk to each other and make something clever. Well, there are approaches trying to do such peer-to-peer communication, like the all-join framework, for example. But I personally doubt that that will really cover all aspects once it's there and there is some common protocol, because somehow a smart home setup, the use cases you have are very individual to your special situation. And the devices themselves can't be clever enough to know exactly what you might want to do and what device is used in what context and should give you notification on what channel and so on. So you will need a way and a place to define actually your personal set of rules and logic and what should happen. So you need some central instance in your setup. If you have such a central instance, you will anyhow need that to still be able to have remote access to your system, to maybe also have some cloud services that do crowdsourcing and clever things there. Nothing against that. But it should be really channeled, and it shouldn't be up to the devices to do all that. It should be really your setup altogether that allows and which clearly defines which data is sent out to the cloud and what is used there. Okay, and as this picture shows, whenever possible, using your smartphone and applications, they should actually be able to connect locally, to act locally, and not do everything through the cloud servers. Okay, so such a central instance, I usually call it a home gateway. That's what Eclipse SmartHome offers as a software stack. So SmartHome, the project, was actually started by an initial contribution from another open source project called OpenHub, the Open Home Automation Bus. And that's a solution purely software based on Java and OSGI with a very modular architecture. And this stack should exactly allow you these things. So to do remote access, to have local connectivity, to define automation rules and such things. Now what exists in Smart Home for that? Well, we define a small domain model. We call that items, where you actually model your physical environment and the functionality you want to control or measure in your home. So these items are not devices themselves, but they're really a functionality. And we really try to keep these two concepts apart from each other, because your device might be an actuator that is down in the cellar on your switchboard, while actually the functionality is the light in the living room that is switched by it. Okay, so two different things. For this domain model, we define different events that can be sent for these things around. And based on these items and events, there are then APIs and services for connectivity, so to your physical systems, and to interact with other systems as well. There are APIs for the automation part, so how do you define rules, how can you make things automated. There are services to define a uniform user interface across all your landscape, which you then can use also across different devices in the same way. And last but not least, there are services around persisting your data or sending it around. So you can either use a local database where you store it to do charting afterwards. You can also send it to IoT services out to the cloud, or use it through MQTT to send it to some broker where you do whatever with the data. Okay, so the core architecture is really the events. You're sending events for your items. The item registry keeps track of the latest status of all your items, which can then be used to trigger your rules, to do a visualization in a user interface of the current status of things, and so on. The physical world is connected through so-called bindings, and these are really just OSGI bundles that you can add and remove to your system, where you can then do a translation between the virtual events, the logical ones, and physically addressing a certain system. Now, having a closer look at what's inside such a binding. An example is here Philips Hue, so this LED lighting system that Philips offers. This comes with a bridge, which is here on the table as well. It's a small IP gateway from Ethernet to Zigbee radio network, because then the bulbs of Philips, they are accessed through Zigbee radio. So first of all, you would have to implement here a special handler for this bridge, which then has the code and know how to read out the bulbs that are connected. And then for every bulb that you find there, you would have an instance of a handler that can then react on that. And the bulbs themselves are the physical device which offer different functionalities. We call that then different channels, which are the functions. And as an example, you might have bulbs that can only do white light, so you can just dim them and nothing else. Others can do really color control, hue, saturation, brightness. But you might also want to use such a color bulb also just as a white one, but change the color temperature from warm to cold and so on. So that's a completely different functionality of exactly the same device. And these different channels then can be bound to our modeled items, and the items appear then as some sort of widget on your user interfaces as well. So you could now decide that actually your color bulb, you would want to have a color picker available for that. Or you could also say, well, you just want to have a switch because this thing has a cool party mode where it's more or less visualizing your music in the room or whatever. Okay, so different functionality, and you can decide then with your setup how to use the device. Okay, just an example here, the user interfaces, you declare them in a textual notation, and different UIs can render them in their own way according to their operating system and so on. But as a user or administrator, you just have to set that up once. Okay, enough of the slides. I prepared a small demo to show you how that all works. I use for the demo an instance of OpenHub because that's at the moment the place where all the bindings exist and the things work together. So To control the things, we use the so-called designer. The designer is more or less an Eclipse RCP application which allows you to textually configure your system and set up your system using Xtext in the background, so you have nice syntax checking, auto-completion things and so on. So what I brought here is one lamp that is actually from Philips using Zigbee and which is connected here to my bridge already. So the lamp by itself is more or less a nice toy. So what you get with that is a small remote control, so you can actually turn it on and off here. You can change the color by rotating, okay. But this is really nothing that you would use to replace your existing main lighting in the room, right? Because you don't want to have such a remote control everywhere to turn on and off. And you also don't want to use your smartphone, take out of the pocket if you enter the room to turn on the light. Okay, so we now connect that to our system here, and for this we can say an item type. Okay, it's a color lamp. We use the color item type and we just give this thing a name, light. That's all for a start. So we have defined our one model functionality here. I prepared already a sitemap, which is the declaration for user interfaces, where I say, well, okay, for this item I want to use a color picker, and we can try that out if that works directly. There we go. So we have a user interface here showing us the light, which we can switch on and off here. Choose a color, but you see nothing's happening here. Well, of course, we didn't configure that this item should be bound to the Hue physical system. So let's add that. To bind that somewhere, we just have to give curly brackets and define now which binding we want to address. And then as a string, we have to configure now what actually should be used on this binding. And here it's a rather simple string. We just have to define which bulb is it that we want to connect to. So that's the first one that we have. Configure it here. And if we go back to our browser and we click here, we see we can directly control the light, change the color. Okay, nice. So far we didn't gain anything because a smartphone app, whether be it Eclipse SmartHome or from Philips, it's the same. It doesn't help you much. Now, one thing to improve your life might already be something like that, an NFC tag. You could put that right next to your switch or even behind the switch at the wall. And this thing is now actually programmed to access this light, and let's try if that works. If I hold it close to my phone, I can turn on and off the light. So the next time, oops, on, did it, on again. So the next time you don't even have to start your smartphone app to turn on and off the light in the room. You just have to hold your phone close to the switch at home, and then you can switch it. Okay, already a bit better, and also very, very convenient, these things, if you want to switch something outside in the garden. You just stick that somewhere and you can easily switch with your phone, a socket or whatever you have there. So quite a nice solution. But you might say, well, okay, you still need the phone everywhere with you. Not really that good. So I brought you something else, which is really now a wall switch, which you can put into the frame at home, replace your existing ones. And the cool thing about this one is that you don't need any physical wires going into that. You don't need any batteries to replace. So it's completely autark, working on its own. It's a technology called EnOcean. So it's a radio protocol. And a special thing about it is they call that energy harvesting. So if I press here, you hear it clicking clearly. And this click, the energy that I put into the system by pressing is enough to send out the radio telegram. So thinking about Paul's security issues from before, the energy for that is definitely not enough to do a lot of encryption on it, okay? But still, for simple use cases where security doesn't matter too much, it's a really cool idea. So I've prepared the according binding configuration right here. And we can add that to our lamp as well. So that's a bit more complicated. Every device here has a unique identifier which is printed on it, so I can just put it in here. Channel A, this thing has 2 rockers, so I just define which one I mean, and a special profile of EnOcean which says how it should behave. So now I've saved that, and let's see if it works. If I press here, do I press the right one? Okay, that's a typical demo effect. It's not even receiving. I have an USB dongle attached here. And this thing isn't even receiving the telegram. So it's not the software that is not working, it's the hardware right now. And the risky part is the last time that I detached the dongle, my whole PC crashed. So I'm not sure if I should do that. Should I, Ben? Yeah? You're sure? No, I count on you that you trust me that it usually always works if I press here, okay? I don't dare to do that. But we have anyhow much better use cases. So, well, one thing was about automation as well. So as I said, you might want to have many things actually happening automatically for you. You don't always want to switch here. So just to give you an idea how you can do that in Smart Home, there's also using Xtext here in the background, and there actually Xbase, which is an expression and scripting language that is available, which is more or less the same basis as the extend language uses, and which is very, very close to Java, but it's embeddable into your own domain-specific languages here. So I prepared here a small example rule, which is already a rather complicated use case. It's easily formulated. It's a staircase light, so you turn on the light and it should automatically turn off after a while, okay? Very easy. The logic behind that is not necessarily that easy. So what we say is that if we receive some command for our light and this thing is on and there is not yet a timer running, then we create a timer to say in 5 seconds we turn it off again. If we have already a timer running, we say, well, we actually want to have a re-trigger functionality. So if I press after 4 seconds again on, then I want really the light to stay on for another 5 seconds. So I reschedule my existing timer. And if I receive anything else but on, so an off, I can actually cancel any existing timer. So if I manually turn off the light, then every timer should be cancelled. There shouldn't be any automatic off event. So we can really write such a rule in very concise syntax here. And if we now, I can use my NFC tag now again. So we turn it off. We have our NFC tag. Turn on the light, and after 5 seconds, if everything works well, it goes off again. Okay. Now, the last nice gadget that I brought is right here on the table. Who knows that? Hopefully everybody. No. Leap motion device. So it's a gesture sensor, actually, working with a stereo camera built inside. And so this thing actually recognizes everything I'm doing above it, okay? So what I want to show here is if we add that to our configuration, leap motion, this one is actually just activating it for that light. We turn that on. Now we can say, well, we don't actually need any physical button or so to switch. We just go here and say, well, switch the light. Why is it's not my day today? Then we go on the command line. Yeah, I can't see it right now, yeah. Lead motion. Is it the rectangle? Which one? Ah, this one. So let's see if the device. Okay, so it doesn't feel connected, then it can't work clearly. But why not? Well, it's lighted, so again, it's some third-party software that isn't working here. Okay, I'm sure I can get it working in the break, so if you're still around, I can show you how that's supposed to work. But yeah, there is a binding for this thing where you can really get the gestures. Actually, I show you that as a video. I have that available, so. Let's go here. So you see, just by tapping with the finger, you can turn on and off the light. You can, just as we did with the physical remote here, rotating the color, you just rotate your finger and can choose then the color with that. You can dim your light, just showing all 5 fingers, going up and down, saying brighter or darker. So that might seem like more or less toying around, but I could imagine that for the future, actually gesture control for home automation can become really relevant, because if you look at things that we have now, color lights, and we don't actually have physical controls available in the houses. So you have switches, you have dimmers, but how to choose the right color, there's really nothing available so far. And I think with having gesture control built into maybe your switches at home, you can really dynamically do many things and reconfigure it and do very clever stuff. So in a few years from now, I can really imagine that might become a standard way to do things. Okay, for the end, just one more slide regarding how does Eclipse SmartHome relate to other projects at Eclipse. So I already mentioned that SmartHome makes use of other things like Xtext, EMF underneath, Eclipse RCP for the designer, and many things more. For IoT especially, well, there's a close integration with PAHO as an MQTT Java client for where I said we can export all the events through MQTT, we can connect different systems through that using an MQTT broker and so on. The Kreuzer project is very interesting, where we want to see how things fit together for the administration side and also for remote management of a system. how that fits together. The new very small OSGI framework called Concierge is very interesting because we run the stack actually usually on a Raspberry Pi and very small devices, low-end devices. At the moment we use Equinox as an OSGI framework, which is more meant for enterprise things and so on, so not really optimized for embedded use. And Concierge will be definitely an interesting platform to use there. And then, well, just not even yet a proposal, I think, just in the working Eclipse Moquette. So Moquette is a Java MQTT broker implementation, which we have a lot of interest in embedding into Smart Home to also allow multi-instance setup for distributed environments and so on, and to build that directly into the system for the events. Okay, for the end, just an overview for OpenHub, what kind of bindings exist there today. So we have around 60 different technologies that can be combined here, which you can attach to the system and make use of it. And yeah, there's almost everything that is relevant for home automation and that you might have come across is available there, as well as some web services and new IoT gadgets and so on. So quite a big community is developing bindings for that. Okay, that's the end. Thanks for your attention. And we might have a few minutes left for questions, as it's anyhow now break as well. So any questions? Please. Yes, so the question is, are there any requirements on the openness of the protocol of a device to implement a binding? Well, yes, of course. We can only integrate devices which are in some way accessible through either a published documented API, or also many things are done through reverse engineering proprietary protocols that are underneath. So the best way is definitely if the manufacturer directly designs it in a way that there is an open API for integration with other systems. Definitely. Any other question? Okay, if not, then I'm around here if you come across other questions. Thanks a lot.